Hello friends, welcome to my channel. Today we will discuss about electric potential due to an electric dipole. So let's start. So first of all, I will discuss about equatorial position. So there is a point P on the equatorial plane of an electric dipole. Okay, and the distance of this point from the midpoint of electric dipole is R. The dipole length is 12. L plus L is 12 plus Q and minus Q at the point A and B. You can use your trigonometry and Pythagoras theorem to find this length, and it will be under root R square plus L square. Similarly, this length PB will be also under root R square plus L square. So you have to find potential. So first of all, the potential due to positive charge at point P is simply V1 equal to, since it is scalar, potential is scalar, so you have to use sign. Okay, you have to put the sign of these charges as well. Okay, because it is scalar. So 1 over 4 pi epsilon naught Q over R. So Q, charge is Q over distance. Distance is under root R square plus L square. Under root R square plus L square. Okay, it is the potential due to positive charge, but the potential of at point P due to negative charge will be V2 equal to 1 over 4 pi epsilon naught charge with proper sign. Okay, we have to use proper sign in the expression for potential. So minus Q over under root R square plus L square. So the total potential, it is the simply sum of all this potential. Therefore total potential at point P, it is simply V equal to V1 plus V2. These two are same in magnitude but opposite in sign. This positive is negative, so these two will cancel each other. Under root R square plus L square minus 1 over 4 pi epsilon naught Q over under root R square plus L square, and they will cancel. Then the potential 0. So you can see, you must note that it is an important condition. All the point on the plane passing through the equatorial will have 0 potential. Okay. So next is axial position. There is a point P lying on the axis of this dipole. Okay. The distance of this point P from the midpoint, midpoint O of the dipole AB is R. The dipole length is 12 and the charge is in the dipole are minus Q plus Q. This is R, so this will be R minus L, and this will be R plus L. We have to find total potential at this point P. So the potential due to positive charge plus Q at point P will be 1 over 4 pi epsilon naught sign charge with proper sign positive Q over distance R minus L, and the potential due to negative charge will be 1 over 4 pi epsilon naught minus Q over R plus L. The total potential is the sum of all the potentials. So they simply add them, okay, with the proper sign. See, it is common in both the expressions. In Q is also common. So you can take them common out, and from you will get 1 over R minus L minus 1 over R plus L. They simplify this expression. So R plus L minus R plus negative will become positive over R square minus L square, and these positive part will cannot cancel. It will be 12. Now see Q into 12. the dipole moment is P equal to Q times 2L. So you can substitute this value in this expression. So you will get V equal to 1 over 4 pi epsilon naught P over R square minus L square, and this is the expression for the electric potential at any point on the axis. Okay. So in dipole length is very small in general, so you can use some approximation since that is very less than R, so you can evaluate this. Therefore V equal to 1 over 4 pi epsilon naught P over R square. Okay. You should note that I have chosen my point near the positive charge. Okay, so my potential is positive. If I choose my point near negative charge, means here. Okay, if I choose my point here, then the potential will be negative. Okay, because it is near the negative charge, so negative potential will be higher in magnitude, so that it will dominate. But here positive potential will dominate. So in general, the potential at an axial point is V axial. In general, okay. In general, V axial is plus minus 1 over 4 pi epsilon naught P over R square. Okay. The sign positive negative depend on the position of your point where you are determining the electric potential. Okay. Now next, you can find the electric potential at any general point. Okay, at any point on this in this space. So let me do it. So you should find electric potential at point P, P of R, theta. Okay, it is the coordinate in planar polar coordinate system. The distance of this point from the center of the dipole is R, and the angle from the between the radial vector R vector and the dipole vector is theta. Okay, so it is the coordinate in planar polar system. So you can resolve the dipole moment in two components. One along this line OP, first component along the line OP, it will be simply P cos theta. So P cos theta component along the OP, and one component perpendicular to it. So it is in the perpendicular direction, P sin theta. Okay, let me do it separately. Draw it. So the component is in this direction, P cos theta. It is P cos theta. It is P sin theta, which is perpendicular to this component. It is P sin theta, and the dipole P is the resultant of these two. It is simply P, magnitude of these two component resultant. So it is something like this. Means it is equivalent to two dipoles placed mutually perpendicular to each other. So the potential at point P due to this component will be V1. Okay, the potential at point P due to P cos theta, that is due to P cos theta, P cos theta component. That is V1. This is 1 over 4 pi epsilon naught C. It is in the axial direction. For P cos theta, this is the axial direction. So the potential in the axial direction is magnitude of dipole moment over distance square. magnitude of dipole moment is p cos theta. So it is p cos theta, and the distance is small r. So it will be small r square. This is the potential due to this component, and the potential due to p sin theta component. It will be simply 0 because it is perpendicular. So for p sin theta, this is the equatorial direction. Okay, this point P fall in the equatorial plane for p sin theta. Okay, so the potential at point P due to this component will be 0. Therefore, total potential at point P is simply sum of these two potentials, V equal to V1 plus V2. It is 0. V2 is 0. So V is simply 1 over 4 pi epsilon naught P cos theta over r square. This is the electric potential at any point r, theta in a plane. Okay, and you can verify this. Okay, suppose theta is 0. Okay, suppose theta is 0, means this point will fall here. It will be axial direction. Okay, so at theta equal to 0 degree, P V equal to, this will be cos 0, cos 0 is 1, so it will be simply 1 over 4 pi epsilon naught V over r square. And we know this is the correct expression for the axial position. Okay, if theta is 90 degree, means equatorial position, then cos 90 will be 0, so V will be 0. So you can simply verify this expression is correct. I hope you will like this video. Please like, share and subscribe my channel.